वीडियो ना। Hello dear students, good morning to all of you. Welcome to you all on the IMS GATE Academy platform. In today's class, we are going to start Laplace Transform. Just confirm audio and video. Vaidehi Purushottam, good morning. So student, till the last session, we have completed the Fourier series and Fourier transform. In today's class, we are going to start a new chapter, that is Fourier, that is Laplace Transform. Chaliye. So all of you guys, just let me know, just confirm audio and video guys. We are going to start in today's class Laplace Transform. So first of all, tell me what is the formula of Fourier transform? I hope you remember. Chaliye. So guys, if I talk about the formula of Laplace transform, then it is nothing but x of s equal to minus infinity to infinity. First of all, if I talk about the Fourier transform formula, then x omega equal to x of t dot e to the power minus j omega t dt. This is the formula of Fourier transform. I hope you know very well. So x omega equal to minus infinity to infinity x of t dot e to the power minus j omega t dt. And we know that to apply the Fourier transform formula, the signal x of t should be absolutely integrable. X of t should be bounded signal. X of t should be a bounded signal, or we can say that the Fourier transform applicable for only, tell me guys, Fourier transform is applicable for energy and power signal. Is applicable for energy and power signal. It is not applicable for any NP signal. It is not applicable for the unbounded types of signal. Tell me yes or no, beta. Purushottam Vaidehi, yes or no? In the Laplace transform, what we are doing? In the Laplace transform, we will able to find out the frequency domain analysis of energy signal, power signal, as well as NENP signal also. It means as well as unbounded signal also. So Laplace transform is possible for bounded as well as unbounded signal. For unbounded signal, Laplace transform is possible for certain range of sigma for which the Laplace transform is finite or converges, and that particular region of sigma is known as region of convergence. Okay. So today's class we will more focus on the region of convergence part, ROC part, because Laplace transform, if I talk about the basic Laplace transform, step signal, ramp signal, that generally comes in the mathematics part also. But in signals and system, what is the unique part, guys? We will discuss the ROC, region of convergence. Okay, chali. So let's start. Here in the Laplace transform, we are replacing S with as a sigma plus j omega. So here we have only j omega. Here I am introducing one more variable, that is sigma. So S equal to sigma plus j omega. If I will make a plane, then sigma will be my real plane and j omega is my imaginary axis, and this is nothing but my S plane. This is nothing but my S plane. So student, the Laplace transform formula will become what? The Laplace transform formula x of S equal to sigma of minus infinity to infinity x of t e to the power minus st dt. This is nothing but the formula of Laplace transform, where S is sigma plus j omega, where S equal to sigma plus j omega. It means your S is a complex number which contain the real part also and imaginary part also. Now student, if I will put the value of S here, then what I will get? I will get the Laplace transform x of S as a minus infinity to infinity x of t dot e to the power minus. Should I write, student, sigma plus j omega inside the bracket, and here I should multiply with t and dt only. So minus infinity to infinity xt dot e to the power minus. Sir, जिस दिन के दर्शन होंगे? पुरुषोत्तम, what you are writing? Purushottam, बोलो बेटा, everything is clear till now? Vedai, Purushottam, all of you. So बच्चों जरा बताओ, xt equal to e की power minus sigma plus j omega into t into dt. If I will just open, I just substituted the value of S beta. So what you will get ultimately? You will get minus infinity to infinity x of t as it is. Just open the bracket here. So it will be e ki power minus sigma t and e to the power minus j omega t into dt. Tell me guys, tell me, is this crystal clear to you or not? All of you guys just do reply. Is this crystal clear to you, beta? So x of S is equal to minus infinity to infinity xt dot e to the power minus sigma t dot e to the power minus j omega t dt, and this is nothing but the formula of Laplace transform only. It means this expression and this expression is still same. Now can I say that, my dear student, the Laplace transform of xt is nothing but, if I will just observe this part, if I will take this as a one signal, then don't you think कि Laplace transform of xt is nothing but the Fourier transform of this particular signal? Laplace transform of xt is nothing but the Fourier transform of xt dot e की power minus sigma t. This e to the power minus sigma t is the additional factor. सर, जिस दिन गुरु से आपके दर्शन होंगे उस दिन सफल मेरा. पुरुषोत्तम, बिल्कुल बिल्कुल डेफिनेटली बच्चा, हम लोग डेली लाइफ में मिल रहे हैं, वैसे फिर भी ज़रूर हम फ्यूचर में डेफिनेटली इफ देयर इज एनी स्कोप विल डेफिनेटली मीट. ओके, चलिए आप बताइए बच्चों, यहाँ पे शैल आई राइट ए स्टेटमेंट कि सर लाप्लास ट्रांसफॉर्म ऑफ एक्स टी इज इक्वल टू द फोरियर ट्रांसफॉर्म ऑफ x of t dot e to the power minus sigma t. So what you should write, बच्चों? Laplace transform of xt is actually equal to the Fourier transform of xt dot e to the power minus sigma t. This is nothing but the expression. Laplace transform of xt is equal to Fourier transform of xt dot e to the power minus xt, e to the power minus sigma t. This is a very important statement. You should write this statement, guys. All of you should write this statement fast. Yes. And once you will complete beta, you should reply. All of you guys will reply fast. Laplace transform of a xt signal is nothing but equal to the Fourier transform of xt dot e to the power minus sigma t. This e to the power minus sigma t will make the difference between the Fourier transform and Laplace transform. Shall we go for next बच्चों? Yes or wait? बोलो बोलो. Yes. Now student, I am taking an example. If I am taking an example ki find out the Fourier transform of e की power 2t ut. Tell me beta Purushottam and Vedai, what is the Fourier transform of this signal? All of you guys tell me what is the Fourier transform of this. All of you guys tell me what is the Fourier transform of this. I am waiting for your response. Come on. What will be the Fourier transform of e to the power plus 2t ut Fourier transform? Come on. Do reply fast, all of you. What is the Fourier transform of this? Come on. E to the power plus 2t ut exponentially growing signal. Tell me what is the Fourier transform of this. This is unbounded signal, sir. Very good. Unbounded signal, so Fourier transform can't determine. Fourier transform can't determine. Fourier transform can't determine. But student, if this is my signal x of t, all of you just focus on the board. If this is my signal xt e to the power 2t ut, its Fourier transform is not possible. Okay. Now I am looking for the same signal Laplace transform xt equal to e की power plus 2t into ut. Now tell me, if I want to find out the Laplace transform of xt, Laplace transform of this xt, and I know that it is equal to the Fourier transform of xt dot e to the power minus sigma t. Yes. So if I want to find out the Laplace transform of xt, if I want to find out the Laplace transform of e to the power plus 2t ut, so don't you think it is equal to Fourier transform of xt मतलब e to the power plus 2t ut, e to the power plus 2t ut multiply with e to the power minus sigma t. I hope it is clear to you guys. Laplace transform of e to the power 2t ut is equal to the Fourier transform of e की power 2t ut dot sigma. Now I can write, student, the Fourier transform of e to the power, if I will take a common here, I will get बच्चों 2 minus sigma into t into u of t. Is this clear बच्चों? I just common in t, so I will get inside the bracket 2 minus sigma. Now tell me beta, Fourier transform of this signal, if I will give you a reason, if my sigma is greater than 2, come on. If I will take sigma value greater than 2, if I will take sigma value greater than 2, Purushottam, if I will take sigma value greater than 2, then tell me Fourier transform possible or not. If I will take sigma value greater than 2, then Fourier transform of this signal possible or not. And it is equivalent to what? Laplace transform of e to the power plus 2t ut. So Laplace transform of e to the power 2t ut is only possible for which reason? For this particular of reason sigma is greater than 2. Because if I will take sigma greater than 2, let us assume that 3 or 4, then it will give me e की power minus 1t. Because 2 minus 3 minus 1, e की power minus 1t, e की power minus 2t. And once it is exponentially negative, it will become bounded and it is possible. So what we can say that कि Laplace transform of e to the power plus 2t ut is possible for this region of sigma, and this region of sigma, that particular region of sigma, this region of sigma is also known as region of convergence, that is known as short form ROC, region of convergence, ROC. So for a particular region of sigma, the Laplace transform of xt is finite or convergence. That particular region of sigma is known as region of convergence. So if you want to write a statement for the ROC, you should write the statement: the region of sigma for which Laplace transform of xt is finite or converges called as region of convergence, called as ROC, region of convergence. So the region of sigma for which the Laplace transform of xt is finite or convergence called as ROC. That particular region is known as region of convergence. Do it fast, बच्चों. Do it fast. All of you guys complete it fast. All of you guys just complete it fast. Shall we go for next? प्यारे बच्चों, just do reply fast. नीरज कुमार, just complete बेटा. नीरज, late हो गए आज, no problem. चलिए. So we just started the Laplace transform बेटा. We just started the Laplace transform. सर थोड़ा लेट, यस, कोई बात नहीं, कोई बात नहीं नीरज, कोई बात नहीं बेटा. जस्ट ट्राई टू कंप्लीट दिस स्लाइड. वंस यू विल कंप्लीट दिस स्लाइड बेटा, ऑल ऑफ यू शुड रिप्लाई शैल वी गो फॉर नेक्स्ट और वेट. वेदर यू ऑलरेडी रिप्लाइड दैट नेक्स्ट. अदर स्टूडेंट्स शुड ऑल्सो रिप्लाई शैल वी गो फॉर नेक्स्ट. Guys, do reply. Shall we go for next? Chali. So now we are going for the next region of convergence concept. Now we are writing the condition for existence of. Now we are writing the condition for existence of Laplace transform. Condition for existence of. Condition for existence of. Condition for existence of Laplace transform. Condition for existence of Laplace transform. So you should tell me बच्चों, if I talk about the Laplace transform formula, then it will give me x of s equal to minus infinity to infinity x of t dot e to the power minus st dot dt. This is my actual Laplace transform formula. This is my actual Laplace transform formula. Yes. Now student, I know that here s is nothing but what? Here s is nothing but sigma plus j omega only. So if I will put this value, the condition is nothing but actually minus infinity to infinity mod of x of t dot e to the power minus st mod dt should be less than infinity. This is the condition. But if I will put the value of s, then it will get minus, I will get minus infinity to infinity x of t dot e to the power minus sigma plus j omega whole bracket t dt less than infinite. Now if you will just break this this term, if you will divide in two parts, then you can get mod of xt dot e to the power minus sigma t and e to the power minus j omega t mod dt is less than infinity. And we know that the magnitude of e to the power minus j omega t is 1 only. We know that the magnitude of e to the power minus j omega t is 1 only. So it means the final condition is look like this, कि sir minus infinity to infinity mod of x of t dot e to the power minus sigma t mod dt should be less than infinite, and this is nothing but the only condition for the existence of Laplace transform. So I am writing the final condition here. I am writing the final condition here. The final condition is nothing but integration from minus infinity to infinity mod of x of t dot e to the power minus sigma t dt should be less than infinite. So this is my condition of existence. I hope this condition of existence is clear to you. Beta. Sigma of xt dot e to the power minus sigma t dt less than infinite. This is my condition for existence of Laplace transform. Just do reply, is this clear or not beta? Just do reply, is it clear or not? Xt dot e to the power minus sigma t mod dt is less than infinity, and this is the condition for existence of Laplace transform. And do you know what is the meaning of this? The meaning of this is this term should be absolutely integrable. 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 Tell me yes or no, guys. This term should be absolutely integrable. All of you guys just do reply. This is the condition for existence of Laplace transform. Shall we go for next beta? Shall we go for next प्यारे बच्चों? Just let me know. चलिए बोलो बच्चों बोलो NOW. Shall we go for next? Once all of you complete, you should reply fast. Yes sir, next. Now student, I am taking a signal as a x of t equal to e to the power minus at ut, e to the power minus at ut, and I know that it is an exponentially decaying signal. So if I will make a curve, it is absolutely bounded signal. Just like this, we have a curve 0 to t. This is my x of t. E to the power minus at ut, if I talk about its area, area is equal to 1 by a. If I talk about its energy, energy is equal to 1 by 2a. If I talk about its Fourier transform, it is 1 upon a plus j omega. Now I am looking for its Laplace transform. Yes. So Laplace transform I can easily calculate by using the Laplace transform, but before Laplace transform I should check the region of convergence. So right now I am writing the convergence by using the formula, but after this I will make a short trick for you, and going forward we will always use the short trick to identify or to define the region of convergence. So student, if I will apply the formula for this, what I will get? I will get minus infinity to infinity x of t, it means this complete function, e to the power minus at into ut dot e to the power minus st dot dt. And if I talk about the region of convergence, then I have to check, because of ut limit is 0 to infinity. So e to the power minus a, e to the power minus at dot, if I will write here e to the power minus sigma t dot e to the power minus j omega t, the condition of existence says that less than infinity. It should be less than infinity. So because its magnitude is 1 only, what is the condition of existence? 0 to infinity. Here if you will make the condition e to the power minus common, so it will be sigma plus a into t, sigma plus a into t into dt less than infinity. Now tell me beta, when it will be absolutely integrable? When it will be absolutely integrable, tell me this sigma plus a should be greater than 0 or less than 0? Whether he Purushottam, Neeraj, tell me. E to the power minus sign is already there. Now sigma plus a should be positive or negative? Sigma plus a should be greater than 0 or less than 0? Come on. Now tell me, sigma plus a is greater than 0 or less than 0? Every student just do reply. Positive. So what is the reason of convergence for this question now? Question is e to the power minus at ut. The question is ROC is, this is nothing but the ROC, and ROC is sigma plus a should be greater than 0, sir. Sigma plus a should be greater than 0. It means sigma should be greater than minus a. It means sigma should be greater than minus a. So if I will make a curve, ROC curve, then ROC curve will be look like this. Then ROC curve will be look like this. This is my ROC diagram, guys. This is my ROC diagram. Now the ROC diagram, it means, shall we say that sigma is greater than minus a? It means if I have the value minus a here, the ROC will be greater than, it means ROC will contain the entire right hand side region. So this is my region of convergence. This is my region of convergence. So this is my sigma, guys, this is my j omega, and this is nothing but my S plane. This is nothing but my S plane. Yeah. So region of convergence including imaginary axis, region of convergence including imaginary axis, region of convergence including imaginary axis. All of you guys just do reply fast, bachcho. Shall we go for next? Now first of all student, now I am looking for the final Laplace transform. So we know that e to the power minus at ut, if the signal is x of t, what is this Laplace transform? Laplace transform formula, if I will apply x of s, I will get minus infinity to infinity e to the power minus at into ut dot e to the power minus st dt. So from the last slide, it is clear that what is its ROC. Now we are looking for the Laplace transform expression. So because of ut, the limit goes to 0 to infinity, and e to the power minus, if I will take common, I will get s plus a into t into dt. E की power minus common, then s plus a into t into dt. So when you will integrate, actually you will get e की power minus का s plus a into t upon minus का s plus a, and whole bracket close, limit goes to 0 to infinite. Now you should tell me, beta, what is the upper limit, lower limit? So when you will apply the upper limit, e to the power minus infinity, 0 only, e to the power 0 upon minus के साथ s plus a and whole bracket close. So don't you think ultimate answer is minus minus plus? The final answer is nothing but 1 upon s plus a. The final answer is nothing but 1 upon s plus a. So it means what you should write, you should make a box. All of you should make a box. This box you need to make. And here you should write e to the power minus at ut. The Laplace transform is nothing but 1 upon s plus a, and ROC sigma is greater than minus a. Sigma. This is the important box, my dear student. This is the important box. So e to the power minus at ut Laplace transform is 1 upon s plus a, and sigma is greater than minus a. Again the same diagram, sigma is greater than minus a. So what I have observed here, this is my minus a, and sigma is greater than a, means covering the right hand side region. So this is the ROC diagram in the S plane. This is the ROC diagram in the S plane. Now student, one important observation. You should tell me first of all, this signal is bounded or unbounded? Tell me. This signal is bounded or unbounded? Tell me. If I will make a curve, I will get a definitely exponentially decaying curve because of e to the power minus at ut with respect to t. So this signal by nature bounded or not? This signal by nature stable or not? So we'll say that this signal by nature bounded only, stable only. So what we have noted, the signal by nature bounded, by nature stable. So in the Fourier transform, in the Laplace transform 1 upon s plus a, if I talk about the ROC, if I will observe the ROC, then I am observing that it's ROC including imaginary axis. Right now I am not making any conclusion, but I am just observing this fact that this signal is by default bounded and stable, and if I will see its ROC, the observation says that ROC includes imaginary axis. So I am just writing a conclusion. Here ROC includes imaginary axis. Here ROC include imaginary axis. This is the first question. That is why I am not making conclusion. We will see one or two more questions, and after that we will make the conclusion. Okay, bachcho? So just complete this part, beta. Once you will complete, you should reply. Vedai, Purushottam, all of you. Take your time and complete this. I am waiting. Once you will complete this slide, beta, do reply fast. बोलो बच्चों, वेदई, पुरुषोत्तम, shall we go for next or wait, beta? So very important box, e to the power minus at ut 1 upon s plus a, sigma is greater than minus a. Yes sir, complete. Purushottam, shabash. Vedai, okay. So now student, clear sir, very good. So student, what is the standard form now? The standard form, that is known as right sided form, we have to remember as a box. This box we need to remember. If e to the power minus at ut, if signal is multiplied with ut, it means the signal is right sided signal, and its Laplace transform standard form, you know that 1 upon s plus a, and its ROC sigma is greater than whatever the value here, t multiple is what? Minus a. So ROC is sigma greater than minus a. The same table we already made here. I am just repeating this. E to the power minus at ut 1 upon s plus a, sigma greater than minus a. Now student, this will work as a short trick now for any right sided signal. For any signal which is multiplied with ut, if you want to comment on the ROC, for the right sided signal, ROC will be always greater. ROC will be always greater. किसके greater? The multiple of t in the exponential. The multiple of t in the exponential. So let me take some example. Suppose that if I am writing this question, that e to the power plus 5t ut, e to the power minus 3t u of t, 1 upon e to the power 5t u of t. Can you please comment on the ROC and Laplace transform? Can you please comment on the ROC and Laplace transform? Here you should comment on the ROC and here you should write the Laplace transform. Here you should comment on the ROC and here you should comment on the Laplace transform. Yeah. Come on. Come on guys, come on, tell me what is the ROC and what is the Laplace transform. All of you just do reply. What is the ROC and what is the Laplace transform? Come on. What is the Laplace transform and what is the ROC? So as I told you already, for the first question, you have to just check whether the signal is right sided or not, because it is multiply with ut, all are multiply with ut. So ROC is greater, ROC is greater, ROC is greater, ROC is greater. किसके greater? Whatever the multiple of t. So here multiple is 5, so ROC greater than sigma 5. Here ROC multiple of t, t multiple is minus 3, so sigma is greater than minus 3. Here is what? It is e to the power 5t. When it will come in numerator, then only we can compare. So it can be rewrite as a e to the power minus 5t ut. So ROC is greater than minus 5. So if I talk about the Laplace transform, guys, Laplace transform will give me opposite sign frequency shifting. So e to the power 5t ut is nothing but 1 upon s minus 5. This e to the power minus 3t ut Laplace transform will give me 1 upon s plus 3. E to the power minus 5t ut, the Laplace transform is nothing but 1 upon s plus 5. So as far as Laplace transform is concerned, this is concerned, but as far as ROC is concerned, here we have mentioned the ROC. Now can you please tell me, pyare bachcho, if I will make the ROC diagram as well, if I will make the ROC diagram as well in the S plane, then you should tell me by observing the S plane diagram, okay. So first ROC is greater than 5, it means here is my sigma, here is my j omega, here is also sigma, here is also j omega, here is also sigma j omega. So if ROC is greater than 5, it means if here is 5, the ROC will contain the right hand side region, ROC will contain the right hand side region, yes. Now second ROC, sigma is greater than minus 3, so of course minus 3 is here, negative axis, and ROC is entire, sigma is greater than minus 3, it means covering the entire right hand side part. Sigma is greater than minus 5, it means minus 5 is here, minus 5 is here, and sigma is greater than minus 5 means like this only, like this only. I hope this part is also clear to you, beta. Now tell me in this question, the ROC is stable. In this question the signal is stable. So of course e to the power 5t ut is an unbounded signal, it is unstable. Similarly, if I talk about this signal, so this signal will give me stable or bounded, stable and bounded. Bolo bachcho, yes or no? Similarly, this one e to the power minus 5t ut is also stable or bounded. Bolo ha ya na? And if I will check its ROC, wherever is stable, can I make a conclusion in both the case, signal is stable. So shall we say that the ROC containing or ROC including the imaginary axis? ROC including the imaginary axis in both the stable case. In both the stable case, ROC include imaginary axis. And the first case is the only unstable. Remaining two is stable only. It is also stable only. So shall we make a conclusion whether it is unstable? ROC does not include imaginary axis. So can I make a conclusion for stability? It is an important property. For stability, ROC must include imaginary axis. ROC must include imaginary axis. Important properties of ROC properties. For the stability, ROC must include imaginary axis. All of you guys just do reply. Shall we go for next, beta? Every student just do reply fast. Shall we go for next? Bolo yes or wait. Bolo. Yes or wait. Chaliye, take your time. Once you will complete this, you should reply N or W. Every student should reply fast. Tell me बच्चों N or W, next or wait. बताओ बच्चों N or W. Next, sir. So student, what we have concluded कि to make the signal stable, for the stability ROC must include the imaginary axis. ROC must include the imaginary axis. Okay. So this is all about the right-sided form. Okay. Now I want to create the left-sided standard form. So I am writing my right-sided form e to the power minus at ut. Its Laplace transform is nothing but 1 upon s plus a, and its ROC is nothing but sigma greater than minus a. Sigma greater than minus a. If here I will replace t with minus t, then property says that time reversal s should replace with minus s and sigma should replace as minus sigma. So ultimately what you will get here e to the power plus t, because minus plus, u of minus t, and its Laplace transform will become what? 1 upon minus s plus a. And what is the sigma? Here you should write minus sigma is greater than minus a. So now you should tell me, you can't make this minus cancel, no. You have to just change the position. So sigma is here only. Now sigma you have to just move in the right hand side, and this minus a come in the left hand side, so plus. So ultimate ROC is sigma is less than a. The final ROC will be sigma less than a. So my standard form says that e to the power at u minus t. This is my left sided. This is nothing but the left sided. This is right sided form, I already told you. And right sided means ROC greater than t multiple, so ROC greater than minus a. ROC greater than minus a. Now here I have generated the standard left hand side form. The standard left hand side form we have generated already. E to the power plus at u minus t, Laplace transform will be 1 upon minus s plus a, and ROC will be sigma is less than a. If I will make a S-plane diagram, then sigma is less than plus a. This is my sigma, this is my j omega, and it is my plus a, and ROC is less than plus a. It means ROC is left hand side to this plus a. So this is the entire ROC region. This is nothing but the entire ROC region. Now you can check this beta. Tell me whether this signal is stable or not. If I will make a curve, this curve will give me e की power plus at u minus t, मतलब exponentially growing curve, but only for the region of minus t to 0. So don't you think e की power plus at into u of minus t, this curve will give you absolutely bounded signal. This is nothing but a bounded types of signals only, or stable types of signal only. Yes, stable. So in the ROC, we will check the ROC. पुरुषोत्तम मिलता है सच्चा क्या बात है पुरुषोत्तम, आज बड़े ही भावुक हो रहे हो चलिए बताओ बच्चों, बताओ. Shall we go for next? प्यारे बच्चों, just do reply fast. E की power plus at u minus t, Laplace transform 1 upon minus s plus a, sigma is less than a. So tell me if it is a bounded, if it is a stable, ROC also satisfy this. Shall I make a conclusion कि here ROC includes imaginary axis. Here ROC include imaginary axis. All of you guys just let me know, is this crystal clear to you beta? ROC includes imaginary axis. Is this crystal clear to you? ROC includes imaginary axis. Is it clear to you? And it also satisfies our property for the stability. ROC must include imaginary axis. ROC include imaginary axis. Yes. So now, student, I am writing the standard form, and I will write the standard result also in a table. I will make a table and will store the results in a standard form. Okay, chali. So here I will write the xt form. Here I will write first of all xt and Laplace transform. Okay. Here I will write this ROC, xt signal and Laplace transform, or you can make a table just like this: xt Laplace transform one side, next is ROC, and next diagram of ROC also explain how the ROC look like. Okay, chali. Okay. So do reply bachcho here. If I am writing the signal x of t here, I will get its Laplace transform x of s here. I will get its Laplace transform x of s here. I will write the ROC here, and I will write S plane diagram here. Make S plane diagram here. Okay. चलिए S plane diagram थोड़ा छोटा बन गया, कोई बात नहीं. चलिए जरा बताओ बच्चों, what is the standard form? E की power minus at ut. What is the Laplace transform? E की power minus at ut. The Laplace transform is nothing but 1 upon s plus a, and ROC sigma is greater than minus a. Whatever we have concluded, this is a summary box I am making. If I talk about this, okay, sir, what about e to the power plus at ut? Then tell me what is Laplace transform, guys? Laplace transform is nothing but 1 upon s minus ka a. ROC ut मतलब sigma greater किसके greater plus a, so sigma is greater than plus a. Similarly, if I will make the standard form, e to the power plus at u of minus t, what is this Laplace transform, guys? So its Laplace transform is nothing but 1 upon minus s plus a. Do you know this guy? E की power at u minus t. Just before this slide we have made conclusion. Left sided form, e to the power plus at u minus t 1 upon minus s plus a, and sigma is less than बोलो बच्चों less than or minus, because of u minus sigma less than plus a. If I talk about this e to the power minus at u of minus t, then tell me what is Laplace transform. So Laplace transform is nothing but 1 upon minus s, whatever this value it will come, so minus s minus a, and ROC sigma is again less than to what? T multiple, it means less than minus a. Bolo bachcho bolo, till here everything is clear or not? If I talk about the S plane diagram, then small S plane diagram I am making. So sigma is greater than minus a, it means ROC contain this region. It means ROC containing this region. This is sigma j omega. For the second question, what is the ROC, guys? For the second question, you must see sigma is again greater than, but this time plus a. So this is the plus a value, and sigma is greater than, it means right hand side region only. This is sigma, this is j omega only. Sigma is less than plus a, it means what, guys? Here we should make a sigma is less than plus a, so here we have a plus a value, and sigma is less than plus a means this is the entire region. Sigma. This is sigma j omega like this. And what about the last one, guys? Sigma is less than minus a, so here is minus a, sir, and ROC is like this. We should also write the statement of stable unstable. So come on, tell me bachcho, ROC sigma is greater than minus a, ROC include the imaginary axis, so should I make this condition is stable only? Tell me what about this, sigma is greater than plus a, shall we say that it is unstable? Because ROC does not include imaginary axis. Don't you think this one is stable? This one is stable because ROC include imaginary axis. But this one is also unstable because ROC does not include imaginary axis. Bachcho, tell me, to make the signal causal signal should be the multiple of ut. Bolo हाँ या ना? If signal is multiple of ut, if signal is containing only the finite value for the right hand side region, then signal is only causal. Otherwise, the signal is non-causal. So shall we say that if any signal is multiple of ut, it will always be a causal signal. We'll also say that the multiplication of the multiplication of any signal with UT will become a causal signal. So we can also use unit step signal. If I will multiply this unit step signal with any signal, the ultimate signal will become a causal signal. So tell me here which one is causal and which one is non-causal. So which is multiple of UT? This is UT, this is UT, so both are causal only. So I am writing here, okay, sir, this one is causal and this one is also causal. But what about U minus T, U minus T? Of course, it is non-causal or anti-causal. So I am writing here non-causal and this is also non-causal. Shall I also make a statement, guys? For a causal signals, ROC must be right side or left side? Come on, whether you should complete this, beta. ROC must be right side or left side? Come on. ROC must be right side or left side? Do reply fast. ROC must be right side or left side? Come on. ROC must be right side or left side? Come on. Do reply fast. So what we will say that for the ROC must be right hand side. So for the causality, we can also make that for causality, ROC must be right hand sided. ROC must be right hand sided. Chaliye. So I think you all guys completed till this slide. Shall we go for next, beta? Purushottam. Causal ROC, for causal ROC must be right. Shabash Vedai, very good. ROC must be right side. ROC must be right side in the S plane. Shabash, should not be in the left side. Chalo, aage chale. I think this slide is completed, beta. I think this conclusion slide is completed, beta. Yes. So now I am taking a first example. Example number 1. Let me take, if my xt is this signal, e to the power minus 3t into ut plus e to the power plus 4t into ut. Now, can you please tell me the ultimate ROC and the Laplace transform? Is there any common ROC? First of all, you should tell me. So, if I talk about the ROC region, then because of UT, ROC sigma is greater. Kiske greater? T ke multiple. So, sigma is greater than minus 3. So, this is my first ROC, sir. If I talk about the second ROC, guys, the second ROC will what? Tell me. E to the power plus 4t ut, it means here sigma is greater than plus 4. Here sigma is greater than plus 4. Now you should tell me ki what is the common ROC. So to make the common ROC, I should make a curve like this. So sigma greater than minus 3 and 4. So I am writing here minus 3 point. And I am writing here plus 4 point. So tell me, bachcho, sigma is greater than minus 3 and sigma is greater than plus 4 also. So if sigma is greater than plus 4, then don't you think this is a region? Yes, sir. Of course, this is a region only. Yeah. And if sigma is greater than minus 3, then this will be the only region. Yeah. This will be the only region. Now you should tell me, bacha, what is the common region? You should tell me what is the common ROC now. Wherever red and yellow, whenever this yellow and white ROC region is there, that is the common ROC. So you know that this is sigma j omega. So if I talk about the common ROC, the common ROC is nothing but sigma greater than 4. So what is the statement? Shall we say that for the right sided signals, for the right side and right side, this is also right side, this is also right side. So shall we say that for the right sided signals, the common ROC will be always right hand side to the rightmost pole. Right hand side to the rightmost pole, because how many pole we have? If I will take the Laplace transform now, because if common ROC is there, then only we can go for the Laplace transform. So e to the power minus 3t ut, Laplace transform is nothing but 1 upon s plus 3. And e to the power plus 4t ut, it means Laplace transform is nothing but 1 upon s minus 4. Yeah. Now you should tell me, beta, okay, here where is the pole? So one pole is at minus 3 and one pole is at plus 4. Yeah. So shall we say that for the right sided signals, the common ROC will be always right hand side to the rightmost pole. Will be always right hand side to the rightmost pole. Is this clear or not? Will be always right hand side to the rightmost pole. Is this crystal clear, beta? Yes. Now tell me in this question, if I talk about the XT, tell me XT is causal or not? Tell me Purushottam, XT is causal or not? Vedai, XT is causal or not? XT is causal or not? Is it causal or non-causal? XT. I am talking about overall XT. I am talking about overall XT is causal or non-causal? XT is causal or non-causal? Come on. है Vedai says that non-causal, Purushottam causal, Neeraj causal. अरे बेटा Vedai, how can it is non-causal बेटा? This is UT multiple, this is also UT multiple. Both UT, अरे both UT, right sided. Now what is why the confusion is occurring? Because some Vedai thought that sir, sigma is -3 na sir. Pole is -3, so that is why I thought. No, ROC, if I talk about the causality, we should only check for the causal signal ROC is right sided. This is also right sided ROC, this is also right sided ROC, and both are multiple of UT multiple matlab causal. So this XT is 100% causal, sir. This XT is 100% causal, sir. This XT is 100% causal, sir. Now tell me, is it causal or stable or what? Is it stable or unstable? Is it stable or unstable, beta? Bolo. It is causal or unstable, beta? It is causal or non-causal? Sorry, sir. Yes, so that is the mistake, beta. Generally, this is the biggest mistake that general students are doing. They are observing the S-plane, and after that they are saying non-causal. Mistake हो गया. No problem. बताओ जरा फटाफट से बेटा Vedai and Purushottam, all of you, is it stable or unstable? Is it stable or unstable, guys? Is it stable or unstable? Stable. So stable it is. Some students are writing stable. Neeraj is writing stable. Arey yaar bachcho. Tell me what is the common ROC? Tell me what is the common ROC. Let me draw the common ROC. The common ROC is greater than 4. Tell me the common ROC is greater than 4. Common ROC is greater than 4. Sigma j omega. If the common ROC is greater than 4, it does not include the imaginary axis. So don't you think it is unstable? Because you have to decide the stability or instability by observing the common ROC. Common ROC does not include imaginary axis. 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 Bolo हाँ या ना? Common ROC does not include imaginary axis. Bolo yes or no, guys? Common ROC does not include imaginary axis. Is this crystal clear, beta? Is it crystal clear, प्यारे बच्चों? Just let me know. Tell me which factor is responsible to make it unstable ultimately. This XT is unstable, na? Due to this factor is stable, sir. This is unstable, sir. This is e की power 4t ut unstable, sir. And unstable plus stable is nothing but unstable. Unstable plus stable is nothing but unstable. So to make xt unstable, this term is responsible. This term is responsible to make xt unstable. I hope this part is clear to you, beta. I hope everything is crystal clear till now. I hope everything is crystal clear till now. Bolo bachcho, yes or no? Yes, shabash. So shall I make a conclusion, beta? If both the signals are right-sided, for the right-sided, right-sided. What is the conclusion for the right-sided? For the right-sided signals, the common ROC will be always right-hand side. This is also right side. This is also right side. The common ROC will be right-hand side to the rightmost pole. For the right-sided signals, the common ROC will be right-hand side to the rightmost pole. I hope it is clear to you. Chali. Now I am also taking one more example. Example number 2. Example number 2. If xt is equal to e to the power minus 3t ut and plus 1 upon e to the power plus 7t ut. Can you please find out the ROC as well as the Laplace transform, guys? I am waiting. I am waiting. You should tell me. I am giving you 30-second time. Guys, just let me know. बोलो भाई बोलो. ROC greater than minus 3. अच्छा. So let me check. चलिए बच्चों. So if I talk about the signal, it is nothing but actually e to the power minus 3t ut and plus e to the power minus 7t into ut. If I talk about its ROC, this will give me the ROC sigma greater than minus 3 and this will give me the ROC sigma greater than minus 7. If I will make a S-plane diagram, here, if I will make a S-plane diagram, then what I will get, guys? I will have a 2 pole, one is minus 3, sir. So one is minus 7, sir. So here you should check the ROC is, both the ROC is right side, sigma is greater than minus 3, sigma is greater than minus 7. So because sigma greater than minus 3, here is the right hand side region, this is the right hand side region, ROC. And here also sigma greater than minus 3, it means here also we have like this. So you should tell me what is the common region, guys. Of course the common region is sigma greater than. Of course the common ROC will be sigma is greater than minus 3. And if I will make a common ROC diagram, sigma is greater than minus 3. If here is the minus 3 and sigma greater than minus 3, this is the common ROC diagram. The common ROC. So tell me it is stable or not. Now tell me this x of t is stable or not. Is it causal or not? Just comment on the causal and stability. If I talk about the Laplace transform, very easy. I am writing Laplace transform here. The Laplace transform will be 1 upon s plus 3 plus 1 upon s plus 7 only. Shabash. 1 upon s plus 7 only. This is my Laplace transform, guys. Now you should tell me, is it causal and stable? So it is 100% UT multiple. So it is 100% causal, sir. And because ROC include imaginary axis, it is stable also, sir. Causal and stable both. Causal and stable both. Shabash. Causal and stable both. Shabash. Chali. So I think, bachcho, as far as reason of convergence is concerned, Laplace transform is concerned, I think this part is crystal clear to you, pyare bachcho. Yes, yes. And very soon on the next week, I will announce a new YouTube initiative also from the 1st August, okay, where I will come with some control system topics also, okay, bachcho. Chali. And that particular sessions will be a 2-hour session, okay, control system session or digital session also I will take. So that particular session I will take for long duration. Here we are having 1 hour because morning I have certain meetings and all. Okay, bachcho, so that's all from today's class. That's all from today's class. We'll meet on the upcoming class. You should just check the upcoming live session and just make a set reminder. Those who are looking for the complete GATE preparation, bachcho, you can share your experience to your juniors also. You should share your experience to all your colleagues. Wherever is possible, you just need to share your true experience. जो भी आपकी सच्ची feeling है, जरूर अपने friends के साथ share करिएगा. And for the IMS GATE Academy subscription, you just visit the website imsindia.com/gate. Once you will enroll in the IMS GATE Academy program, you will get 800 plus live lecture access. You will also get e-lecture access, recorded lectures access. You will get 26 to 30 hard copy of booklet which contain theory book, exercise book and containing 4000 plus practice question. You will also get the access of test series, 130 plus test series including subject test. Sir, with due respect, sir, आज आप बहुत अच्छा लगा. अच्छा, thank you so much, बेटा वैदई, thank you so much. चलिए. So, bachcho, you will get 4000 plus practice question, as well as you will also get 130 plus test series which include exercise, which include what? Which include subject test, multiple subject test, advanced level subject test, as well as the mock test series. Okay, and once you will enroll, you will also get the dedicated doubt solving portal, bachcho, where you can ask your doubts as well, and 12 1-to-1 many my plan session, mentorship session also you will get. Okay, bachcho, chali. So bye bye, bachcho. Thank you, Vedahi, Purushottam, and Neeraj. You all are attending live and consistently replying. Shabash. हाँ बेटा नीरज, for control system from 1st August, whenever I will take the long duration, okay, as compared to this, will increase the duration, okay. But for signals, we'll keep 1 hour session because continuously I am having other works also. As you know that I am handling here complete GATE department, so I need to meet with different team members, mechanical, civil, different team members. So chaliye bachcho, thank you so much. Bye bye. Take care. Love you all. We'll meet on the upcoming class. Upcoming class link is already in the upcoming live stream on our YouTube channel. Okay. So you will get more number of videos from the August month. Okay. Not only for EC electrical branch. If your friends are from mechanical, civil, other branches, you should also convey this information that follow the IMS GATE Academy YouTube channel, where Ankur sir is planning the very good content lectures, YouTube lectures, free lectures for you all, including mechanical, civil, computer science, instrumentation, all the branches. Okay, bachcho? Chali. Bye bye, pyare bachcho. That's all from today's class. We'll meet in the next class. Thank you.